Hello everyone, welcome to this new video, and I will be explaining the problem maximum value at a given index in bounded array. So this problem is exactly medium one, and this kind of problems are become I have realized that they are asked regularly. These are binary search problems. So in this video, first I will be explaining this problem through an example, and then I will code it. So what the problem is basically saying is that I have been given an array, okay, and I have been given a particular index, and I have been given a particular sum. The sum of the array has to be in the limit of this maximum sum, and I have to maximize that particular index, okay, keeping these conditions in mind. So these conditions are that the sum of adjacent numbers should be difference should be less than equal to 1, and basically the sum of the entire array should be less than the maximum sum. So let's understand this problem more clearly from this example. So in this example, let's see this this is let's see this example. So this is in this example, n is equal to 6 and index is equal to 1. So and the maximum sum is 10. So what I have to do is that I have been given an array of 6, and I have to maximize the index that is present at 1, and the entire sum of the array should be less than what? It should be less than 10. Okay, so let's see. So what I will do, that I will just do it by fixing, instead of thinking that what I have to do on the left side and do what I have to do on the right side. What I will do is that I will fix this number and then calculate that, okay, what can be my possible left side and right side. Okay, so for example, if I say that, okay, let's fix my number to 10, then to minimize the sum of this entire array, what I will do, and keeping in the condition that the difference between adjacent should be less than equal to 1, so what I will do is that I will write this as 9 8 7 6, and in the left side I will go 9. So the entire sum here is going to be, I think, somewhere around 30 or 45, 30 I guess. So in this is not satisfying this condition. Now what I will do is that I will go for, say, 9. In case of 9, these things are happening. The sum is still going to be more than 10. Okay, so now and so on. I will come at 4. At 4, what I do is that, okay, to keep the conditions valid, I will write this 3, this 2, this 1, and after that, after 1, I can't go below 1, because it is given that all the elements in the array should be greater than 1. So in that case, I will write 1 only. So here the sum is going to be what? It is still going to be less than 10, greater than 10. It is, I think, 14. But in this case 3 2 1 1, so it is what? 5 8 7. So in this case the sum is 7. So this is a valid case, and everything is being satisfied. So my answer will be 3, because so that's the thing. So to do this, there can be two ways. So either I can go from 10 all the way down here, so this will give me a time limit exceeded, or another thing is that I can use binary search. Okay, so what I will do is that, first, my maximum sum is 10, and the minimum sum that I can reach here, a minimum target value I can reach here, is 1. Okay, so the first one, let's say, first I will take something as 5. Okay, I will explore 5 and see, okay, the 5 sum is some, let's say it is 1000, and I will realize, okay, it is 1000. Now I have to go down, so then I will go to 2. At 2, I see that its sum is less than 10, so I will go up. So in this way I will arrive at my solution more quickly. So this is the idea. So now let's code it. It will become more clear as I code it. So let's begin. Let's go full screen. Please subscribe to my channel. A lot of my viewers are not subscribed, so if you are a regular person here, please consider subscribing. Okay, so first of all, what I will do is that I will make a few integers variables. Int r is equal to n minus index minus 1. So what r is basically, just let me clear this. So R is basically the number of empty spaces in the right side, and I will make another variable L, that is going to be the number of empty spaces in the left. So in this case it is 4, R is 4. So and then I'm using long because there is a integer overflow if I use int. Okay, so L is equal to what? Index mean, it means that basically one is on the left, one only one empty space is on the left. Now I will make more variables. Long high is equal to what? Max sum, and long low is equal to 1. So these are going to be my initial high and low for the binary search. And I will make another variable called long res is equal to 0. This is going to be my maximized value. Okay, now what I will do is that I will write a binary search. So while low is less than equal to high, what I will do is that I will take long mid is equal to what? High minus low by 2 plus low. So this is also done to avoid integer overflow, but in I have tested it, you can also write high plus low by 2. So and now I will make another variable called long sum. So sum is equal to initially it will be mid. You know why? Because so suppose after doing this I arrive at 6, so I will have my sum will initially be 6, then I will calculate this thing and this thing. Okay, so initially the long sum is mid, and long ls is equal to 0. I will explain it what this means. Long rs is equal to 0, and long m is equal to mid minus 1. So just so ls is basically the sum on left and rs is sum on right for that particular. So for example, in this case ls is what? 5 plus 4 9, 9 plus 3 12, 14. ls is 14 and rs is 5. And m I will use it to calculate the sum. So m is basically 5. M will be 5, as it is clear. M is mid minus 1. So I will have to calculate the sum now from 2 to 5. So that is why not 6. So that is why I have just made it m. It is just for convenience. So now there can be two possibilities. So the first possibility is, as you can see, you will see here that in this case, let's see this case. So in this case, this sum is going from 9 to 6. Okay, so it is fine. I can do, there is a formula to calculate sum of n natural numbers. I hope you will be aware of it. N is equal to n plus 1 by 2. So in this case, what I can do is that I will calculate the sum of 1 to 9, and then I will subtract the sum of 1 to 5 to get this particular sum. Okay, I hope it is clear to you. So it is fine, but in this case, see this case. In this case, my 2 1 is going to get over here, and I will have to add extra ones to fill this array. So this will be a different case. This will arrive when what my m is, the number of spaces here is more than m. So m is 2, but the number of spaces here are 4. So in this case I will have to add extra ones. So these are some things that I will write and I will explain it. So if r is less than equal to m, right side, then what I will do is that rs will become what? M into m plus 1 by 2 subtracted by what? M minus r into m minus r plus 1 by 2. So I hope you are understanding. This is just what? To calculate this sum from 9 to 6, what I will do is that I will just from I will calculate the entire sum from 1 to 9 and subtract the sum from 1 to 5 natural numbers to get this particular range. So this is what I am then done. For else condition, I am going looking for this kind of situation where I have to fill extra ones to complete my array. So in this case my rs will be what? M, this thing will be same, control c, control v. and I will add some extra ones. 1 into what? How many extra ones I will add? That will basically be r minus m. So, I strongly suggest you that please pause the video and let this thing sink in, that what this maths formula means. Okay, then you can move forward. So in this way I have calculated the right side. Now I will calculate the left side. So in left side also there going to be a similar condition. If L is less than equal to M, actually this is all going to be same. Control C, Control V. So instead of L, I am RS, I am going to write LS, and instead of M minus R, I am going to write M minus L, and here also it will be L. So it is just a replacement. Just a second. Now what I will do is that I will calculate my sum. So what sum I have arrived so far? So the sum will be what? Sum plus equals to ls plus rs. Okay, now I have arrived the sum at this particular, say at this particular what case I was at this particular case. What is the time? It is 11 minutes. Okay, so now what I will do is that if the sum is less than equal to max sum, then I will simply res is my update my result is equal to mid, and I will increase my low is equal to mid plus 1. And if else if the sum is exceeding the maximum sum, that means that I will have to reduce my high. So my high will become mid minus 1, and that's the problem. It is done, and in the end I will return res. So let's decrease the font 12 pixels. So I think that is done. Let's run this code to check if there is any error. It is running fine. Now let's submit it. It is 100% faster in both time and space, so it's a pretty good thing. So, if the problem is clear to you, please consider subscribing my channel, and have a nice day. Goodbye.